In checking out my new signal generator that I built, I have noticed in the waveform that there is quite a lot of noise. So I think this is the perfect opportunity to try out adding a decoupling capacitor or a bypass capacitor. I'm going to add 3 values for the VCC, and I'm also going to add a second line of VCC so that it has less resistance getting to the actual signal generating unit and the clock. Let's check it out. Now I'm back. I added my decoupling or bypass capacitors, and different names, into the circuit. Right here is the VCC of that clock generator, signal generator, and what I added is a picofarad range, a nanofarad range, and a microfarad range capacitor in parallel right next to it. Now it's really important that this is right next to it, because if it's further away, the inductance of the actual wires will affect the performance of it. And the reason you'll have these smaller values with a larger value is all of the different clock speeds that this has, you need to help out. Now every time it draws a little current, it might have a little dip in the voltage supply if it can't compensate for it, and these are like little quick acting batteries that will compensate for that and try and keep that voltage at a steady level. These only let out the amount of voltage that you actually put into them, so you can actually use way higher voltage rating capacitors than you need, but the microfarads, nanofarads, and picofarads of them have to be matched to the actual use of them, because that's the speed that they'll discharge is what it has an effect on. And these are also good at power supplies or voltage regulators, just to make sure that there's something trying to compensate in the system for any kind of momentary big draws. Like you have a lot of logic, like CPUs and logic chips and things that require a steady control voltage, and if it dips under, you get errors and things. So these decoupling capacitors are perfect for that. Now if you've just rectified something and say like an AC adapter that adapts AC into DC, once you've rectified it, the diodes only leave the peaks of the positive power, so you use decoupling capacitors to smooth out those peaks into a steady DC voltage. And you have to have enough capacitance, because any little load will draw that right back to where you started. So it's kind of a balancing act and a lot of math and trial and error. Let's see how this burger works. Yeah. Check that. Yeah, she looks really good now. Perfect. So, yes it did. It worked out perfect. Look at that laser perfect frequency. No spikes, no jumps. They got rid of those jumps perfectly. They look sharp. So that's what you really want in a signal generator. You don't want a bunch of noise jumping around and goofy stuff, because if you're going to send it through like a circuit to test it or try and use it as a carrier signal, that'll give you a bad day. I think it worked out great. See you guys next time.